Hi Precalculus, this is question number 7 from the chapter 3 review. It says determine an equation for a rational function that is an odd function, has one vertical asymptote, one oblique asymptote, and no x-intercepts. So this is one of those where you can, there are tons of different solutions to this. First thing I do if you haven't gotten a chance to attempt this problem is sort of read it over, try and sketch something, figure out what this equation should look like. I'm going to start graphically too. For me, that seems a little more logical to say, maybe come up with a function visually that satisfies these constraints, and then see if I can come up with an equation for that. So it has to have, it's an odd function, so symmetry, odd means, in this case, symmetry about origin. Okay, so I'm already visualizing something where if something's happening on the first quadrant, it's happening simultaneously at the third quadrant. Similarly for the second and fourth. No x-intercepts, one vertical asymptote. So already, if it has only one vertical asymptote and it is odd, then that gives us a constraint where if I had a vertical asymptote here and it were an odd function, I'd also need to have one on this side for it to be symmetrical about the y-axis. And since I can only have one, that vertical asymptote would have to be at the origin, or at x equals 0. It would have to be the y-axis itself. Okay, so x equals 0 is vertical asymptote. Right? Now we can think in a similar manner about our oblique asymptote, that if our oblique asymptote is up here, then we'd need a corresponding one down here so that it preserves that symmetry about the origin. And since we can only have one oblique asymptote, it must go through the origin as well. I'm going to try and make it as simple as possible and make it sort of this y equals x line is probably straightforward enough. It wouldn't have to necessarily come out to that, but just for right now, I'm going to sketch it in that way. So this is my oblique asymptote, and then it can't also cross the x-axis at any point. So already I'm imagining maybe some function like this that behaves like this and like this. Now we can all pull up Desmos or our calculators and see if we can come up with some of these. We were assuming that this line was going to be y equals x, but if I want, in order to come up with such a function, I can say that the asymptote is going to look like y equals x as x gets really, really big, but the limiting part that would disappear as x gets really big is maybe 1 over x, so something along those lines. Or this would have an asymptote at 0, and so it would be undefined. I could try that sort of function out, and I think that ought to work. I could write it as, if I write something with x on top, x plus 1 or 1 over x plus 1. We're going to try a bunch of these functions out and see which one fits these constraints. And I'm going to do it on my calculator right now. Let's try the first one. Y equals x plus 1 over x should work. This should be the first function we wrote down. So let's start with a standard window. Oh, okay. This seems to fit those constraints. No, it's an odd function. One vertical asymptote, one oblique asymptote, no x-intercepts. This one works. In my mind, I just want to try and see, oh, this would not work because this would have a horizontal asymptote at y equals 1, okay, because it's not bottom heavy. And 1 over x plus 1 would not have a vertical asymptote. It would have a vertical asymptote at negative 1. Okay, so those were just thoughts that crossed my mind. This is the one that sticks out. This one, because once I had decided that my oblique asymptote was going to be y equals x, I knew that, like we did in a previous problem where if you did long division expressed a polynomial quotient or rational function as a mixed rational function or mixed function, then you would, it's this trailing term that would go to 0 as limit x gets really big in the positive or in the negative. and so I wanted y equals x to be my oblique asymptote, goes through the origin, and then simultaneously the simplest rational function I could think of was 1 over x, and it requires that we don't have any x-intercepts. Okay, so it's a tough one to come up with, but you could also type it as x squared plus 1 over x, and there you could do the long division, x squared plus 1 over x, and I mean, you wouldn't do long division, you'd just separate the denominator, but that's the answer that best fits. Now, we could also come up with a whole family of functions if any constant c of x plus 1 over x should work. So here, for instance, if I plug in 3x plus 1 over x, I should have a function that satisfies those constraints. It just has a steeper slope, and still is symmetrical about the origin. Okay, I could go 0.2 and have a way flatter looking. Oh, I sort of like that. Oh, this will not have an oblique asymptote. I apologize. This one wouldn't work. Oh, sorry, 0.2x is what I meant to put in here. Okay, let's try that. Still is odd. Has a vertical asymptote at 0. Oblique asymptote just 1, and no x-intercepts. Okay, hope that helps.